Okay, so chapter 4 is on chromatographic separation. So we are going to learn about the general description of chromatography. Once again, this is chapter 4 and lecture 8. Okay, so these are the things that we are going to learn. We are going to learn about the principles of chromatography, classification of chromatographic method, important terms to describe chromatography, quantification, and also the general elution problem. But before we proceed. Okay, what is actually chromatography? Okay, so you cannot recall it. So normally, if for example, if you watch what we call that investigation channel. Okay, for example, CSI. Okay, when we watch example CSI, SUV, cerita-cerita yang berkaitan dengan investigation macam tu, kan when what we call that investigator tu dapat sampel, okay, so dia akan bawa ke lab, and dia bawa ke lab, dia akan apa begitu, tengoklah sampel tu sama ada sampel baju ke, sampel makanan ke, sampel blood ke, okay, so and then dia akan nak apa pun gitu, kita nak tahulah apa analyze apa benda dalam sampel tu. So kita kena buat first kita buat sample treatment lah, and then lepas tu kita pun masukkan dalam satu benda ni, dan dia akan keluarkan benda tu apa dalam tu. For example, kalau dalam blood kita tengok, oh okay, dalam blood orang tu ada apa, so kita tahulah kenapa dia meninggal semua tu kan. So that is example of chromatography lah. Okay, it is actually a separation method. Okay, so before we go to chromatography, we have to know what is actually separation process. It is actually a method to achieve any mass transfer phenomenon that converts a mixture of substance, okay, into two or more distinct product mixture. For example, here you have sample mixture. Sekarang kita nak separate this. Kita nak pecah-pecahkan dia jadi 3 fractions like this. So this is separation process. Okay, and how to separate all this? Dia mesti ada perbezaan. A, B, C needs to have difference in something, so that kita boleh pisah-pisahkan dia. Kalau dia semua sama, impossible lah kita boleh pisahkan dia. Tapi kalau semua sama, dia dah tak jadi benda lain lah. It is the same thing. Okay, so in this phenomenon, either at least one of this product is enriched in one or more of the mixture constituents, or the mixture is fully divided into its pure constituents. Okay, there are a few factors that affecting the separation between constituents of a mixture, which are, we're going to look at the size, shape, mass, density, or chemical affinity. So if you're having any of the difference in any of these, kita boleh separate lah. If no single difference can be used to accomplish a desired separation, we may use multiple operation which often be performed in combination to achieve the desired end. Okay, so let's say kita nak pakai dia punya mass, tak boleh pisahkan. Mass lebih kurang. Ataupun nak pakai shape, tak boleh pisahkan juga. So mungkin kita boleh pakai combination. Contoh kita pakai shape dan juga mass. Ataupun kita pakai density dan juga size. Ataupun kita pakai chemical affinity dengan density. Okay, so that one is combination of the differences. So boleh jadi satu ataupun combination lah. So separation process are important in some field such as synthesis, industrial chemistry, biomedical sciences, and also of course in chemical analysis. Okay. So this is some of separation method or technique. Before we go to chromatography, kita tengoklah dulu sikit. So precipitation for mechanical phase separation, we have precipitation also filtration. Okay, so you have done this one in session 271 if I'm not mistaken. Kita kan ada what we call that, kita ada satu experiment in which kita nak differentiate organic solvent and aqueous solvent. Kita nak dapat dia punya KD semua tu. Okay, so that one is involving precipitation and filtration. So when we can use precipitation and filtration to separate our mixtures? We can use it when you analyze, for example, in a mixture you have analyte A. Okay, hold on. You have analyte A, B. Okay, so A and B has different solubility in your solvent. Okay, so you are going to have your solvent, right? So you have different solubility. So let's say A is more soluble in the solvent than B. So bila kita buat precipitation, B tadi akan precipitate. So dia less solvent, dia less soluble. So dia akan precipitate. Bila dia precipitate, kita pun boleh filtrate dia. Kita boleh filter dia. Tinggallah A. So sekarang kita dah boleh pisahkan A and B bila kita buat precipitation and filtration. Okay. For distillation, when can we use distillation? Bila kita boleh pakai distillation? Okay, you can use distillation when your analyte, okay, for example, A, B, C, has different in volatility. When we see difference in volatility, means the boiling point is different boiling point. Okay, when this what we call that, these analytes have different boiling point, of course you can separate this. Kita buat macam mana? Kita panaskan lah. So the one with the lower boiling point akan keluar dulu, leaving the one at higher boiling point. Lepas tu kita keep on increasing the temperature. So yang kedua pula akan keluar. Okay. So this one example of distillation, dekat fractional distillation lah. We have fractional distillation. Dekat mana? Okay, so remember dekat yang kita balik macam Terengganu semua tu kan, yang kita ada tower tinggi-tinggi tu. So that one. Contoh fractional distillation lah. Okay, crude oil dapat daripada ni kan. And then kita masukkan kat situ. Okay, so crude oil is made up from a lot of hydrocarbons. So kita panaskan, dia akan keluar lah. The lowest boiling point akan keluar dulu, followed by other. So in that scenario, kita boleh pisahkan lah. Kita boleh pisahkan diesel, petroleum, kerosene, because all those have different number of carbon, thus it have different boiling point or different volatility. Okay, and number 3 is extraction. When you can use extraction? When you also have different solubility into immiscible liquids. Okay, so you have liquids, okay, then it is immiscible. Kita pun boleh buat extraction. Okay, kalau miscible tak boleh lah, nanti dia bercantum. Okay, di combine. Ion exchange, we use ion exchange when we want to separate samples or analytes that have difference in interaction of reactant with ion exchange resin. So ion exchange ni kita akan ada apa? We are going to have resin. So resin exchanger. So resin exchanger ni contohnya kalau kita nak exchange cation ion, kita akan ada negative resin. Kalau kita nak exchange anion, kita akan ada cation resin. Contoh paling ni ion exchange ialah yang sekarang semua ada lah dekat rumah kan. Normally apa tu, kita ada water purification atau water filter. Okay, so bila masuk tadi air tadi, normally air ni dia akan contain benda lain. Ada contain apa panggil tu, kadang-kadang ada contain metal. So metals ni positive ions, right? Okay, so positive ions tadi boleh lekat dekat resin tu, dekat ion exchange resin. So yang keluar ialah your pure water. Sama juga kita nak buang klorin kan. So klorin kan kita guna untuk pembersihan air. So kita nak buang klorin tu, kita pakai anion exchange resin. So anion tadi akan lekat dekat resin tu. So yang keluar is your pure water. Okay. And chromatography. When you use chromatography, when you have different rate of movement of solute through a stationary phase. So after this, we are going to look at chromatography. For chromatography, kita akan ada dua lah phases, stationary phase and also mobile phase. Electrophoresis, we use it when you have difference in migration rate of charged species in an electric field. While field fluid fractionation, we use it when we have difference in interaction with the field or gradient applied perpendicular of transport direction.